Okay, so here's a video, and we're on page 2. So let's see if we can. I know it's Saturday, really nice outside, but it's going to be cold tomorrow. So hope you guys enjoyed the day. Here we go. Page 2. It's 2/5, and you want to use a model here. So I'm gonna draw here 2/5. So let's assume that you have something. And what is this? Cake. 2/5 of a cake. 2/5 of a cup. All right, so we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is what you have right now. 2/5. Okay? And you want to divide it by 3. You want to take that 3 and divide it into 1, 2. There's 3 cups. You have frosting, and you want to put these equally into these 3 cups. Okay? So, what you want to do, obviously, is divide. So let's divide. And because you're dividing in 3, okay, you want to take each part, and that's your cube here. So divide the first into 3, and the second part also into three parts. Okay? So, this enables you to take the first 2, this first 2, to the first cup, the second 2 to the second cup, and the last 2 to the third cup. Alright, now you're going to think that you have 6 pieces, whereas where you started with 2 in the beginning. Okay, you're right to a point, but it's 6 here out of 15. Why is it at 15? Because if you cut each piece into 3s, you got to remember that even though you don't have the others, you don't have frosting on the other pieces, you still need to cut them. Okay, so in essence, now you have, let's see, 3, 6, 9, 12, 15. So you have 15 and you have 6 filled with frosting. So if you have 6 over 15, like I said, these 2 go here, these 2 go here, and the last 2 go there. So each cup of frosting gets 2/15, 2/15, and also 2/15. Okay? Alright, so it says, rewrite the problem as a multiplication question, then model the answer. Okay, easy enough. Half divided by 6. Remember, you're multiplying by the reciprocal, so half times 1 over 6, and you get 1 over 12. So let's see if we can use a model to prove that. So here's something that's cut in half. Okay. I'm sorry, this is 1 over 12. So half and half divided by 6. So again, you have something half and you want to cut it into 6. So you're going to take each half and cut this one in half. In 6s, I mean. 1, 2, 3, 4, 5, 6. But remember, if you cut this in 6, you must cut the other one in 6. 2, 3, 4, 5, 6 pieces. Okay, so if you have half, and we're going to ignore, okay, so ignore this side here. Ignore, because you don't have it, okay? But focus on this. So if you have a half, which is this part right here, and you divide 6 parts, each part is going to be 1 over 12. So that's 1 over 12. This is also 1 over 12, 1 over 12, 1 over 12, 1 over 12, and 1 over 12. So if you have half a cake and you want to divide among 6 friends, each of them get 1 over 12. Okay, so there. Your model backs up your problem. Okay. All right, let's go scroll down a little bit. All right, so 2, that's page 2. Now we're going to page 8. 6, 7, 8. So on page 8, whenever it shows up, so you have 12 pizzas, and each person will eat 3/8 of a pizza. How many pizza can George feed? Does it tell you which way to do this? Doesn't tell you the model. Alright, so in this case, well, I won't model because actually I'll draw 12 pizzas. Okay, so you got 12, so let's see if we can do this. 12 pizzas, and you want to divide it into 3/8 because everybody's getting 3/8. Alright, so multiply it by its reciprocal. 12 times 8 over 3. Remember, we're going to put 12 over 1, multiply across, and you get 8 times 12 is 96 divided by 3 over 3. And you want to take this and simplify, and you can. If you simplify 96 over 3, it becomes 32 over 3, which you can then change to a mixed number, and that's going to be 10 2/3. Okay, so if you have 12 pies, okay, and you cut them in 8 slices, and everybody gets 3/8, you can feed 10 people, and that last person, that 11th person, will only get 2 out of the 3 slices he's supposed to get. Okay, and let's lower this. The Lopez family has adopted 6 miles of trail on the Erie Canal. Each family member cleans up 3/4 of a mile. Alright, so how many family members will be needed to clean the adopted section? Alright, so this one, you know what? I'm actually going to draw. Pretend that's a mile. Let's pretend that's another mile. 2 miles. 3. Okay, and then we have 4 miles. Okay, 5 miles. 6 miles. So, and we're going to represent this, and each one is cut into fourths. Okay, each mile is cut into quarter miles. Okay, so let's assume that your family adopted that section of the highway, and you are to take care of it by cleaning it. So 3/4 of a mile. So every family member cleans 3/4 miles. So here's 3/4 of a mile. That's 1 family member. Let me do it the other direction. Another 3/4 of a mile. That's a 2nd family member. Clean that up. And then I'll continue down here. That's a 3rd family member cleaning that up. And then another 3/4 of a mile. That's 4 family members. Another 3/4 of a mile, 5 family members. With these 2 at the bottom is 3/4 of a mile. That's 6 family members. Another 3/4 of a mile. That's 7 family members. And 8 family members are needed, okay, to clean that particular section of the highway, 6 miles. If you adopt 6 miles and everybody gets 3/4, you need 8 family members. It's a big family. Probably cousins and aunts should be invited to do that. Okay, that's page 8. On page 12. Okay, let's do page 12. Okay, division. Alright, there's 2 ways. Sometimes I can't speak. There are 2 ways of doing division. One is by multiplying by its reciprocal, and then the other way of dividing, which is the easier way, when the numbers are small, is when the denominators are the same. That makes it so much easier. When the denominators are the same, this is what you can do. You can actually eliminate the bottoms, and it just becomes 9 divided by 3. So the answer is 3. Okay? To prove it to you as to why I can cross out the bottoms when they're the same, and it just becomes, I will do this doing it by multiplying. 9 over 12 times, we're going to flip that, becomes 12 over 3. Okay? 9 over 12 is 9 times 12 on top is 108. And 3 times 12 at the bottom is 36. And 108 divided by 36 gives you 3. Same exact answer. Okay? And it's even much easier when you're drawing. So here you got, let me see if I can do 9 over 12 Can't do rectangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 9 out of 12, if I counted that correctly, would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me go back 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 out of 12. Now, the idea is, if you have 9 out of 12, you want to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, this is what 9 over 12 divided by 3 over 12 looks like. So 9 over 12 is the top one, 3 over 12 is the bottom one. So how many times can this right here fit in there? So you need to make groups of 3. So let's see. That's 1, 2, 3. That's one group. 1, 2, 3. That's another group. And 1, 2, 3. That's your third group. So 3 over 12 fits inside 9 over 12 3 times. Ain't that a beauty? Okay, so I think nobody shares my enthusiasm. 7 over 9 divided by 3 over 9. And again, when the denominators are the same, you can actually do this. And this problem becomes 7 divided by 7 over 3, okay, because that's what 7 divided by 3, or if you change the mixed number, 2 and 1/3. Okay, and I'll prove it again. Let's use the model. You have 7, 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to draw 9. And let me draw the other one here at the bottom. And here you have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we are interested in 1, 2, 3, 4, 5, 6, 7. And at the bottom one, it's 1, 2, 3. So how many times can these, a group of 3 nines fit into 7 nines? Well, let's count. 1, 2, 3, it can fit one time. 1, 2, 3, it can fit a second time. Okay, so that's my whole number 2. So it can fit 2 times, and this 3 can fit inside this one time, which is the numerator here, out of the 3. So the last one, out of the 3 that I'm trying to fit in there, I can only fit 1. So 1 out of 3. So therefore my answer is 2 and 1/3. Okay. Let's see. And then we have, yeah, that was it. 2 questions in one sheet. That's a lot of paper. 12, and we're going to page 15. 13, 14, 15. In 15, there's also only 2 questions. My goodness. Okay, so 13 over 10. And we're dividing this by 2 over 10. Okay, so I don't know what the question said, but I'm assuming they want us to draw a model. No? Did they say anything about model? Okay, what page is this? 12? For the following exercises, rewrite the division problem. Be sure to draw a model. Alright, so I'll do it both ways. So, it's on page 15. You got 2 problems. So it's 13 over 12 13 over 10 divided by 2 tenths. So 2 ways. Let's do this 2 ways. Okay, so let's draw a model. And you need something that's cut into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you know another one cut into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's shade these. And yeah, let's just use black. We can use black. So we have 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, 10 tenths, 11 tenths, 12 tenths, 13 tenths. Okay? So you have something that's cut up. You have this 1 tenths. How many 1 tenths do you have? You have 13 of them. Okay? And then you want to see how many times 2/10 fit in all the above. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 2/10 would be these two right here. So how many times can these two fit on top here? So it should be easy. That's 1, 2, so that's once, another 2, twice, another 2, 3, another 2, 4, another 2 over here, 5, another 2, 6. So you can fit it in 6 times, okay, right up to here 6 times. And then the 2, you're trying to fit it in this last 10th here, but you can, out of the 2 pieces, you can only fit 1 out of 2. So your answer is 6.5. If you want to do it, like I said, when you're dividing fractions with the same denominator, you can actually do this. Okay, and that becomes 13 divided by 2, or 13 over 2, which as a mixed number, 2 goes into 13 6 times, and 1.5 left over. So either way you do it, like that, or with models, obviously your answer should be the same. Okay? Need a new page. Here we go. All right. So, and the next question you have is 11 over 9 divided by 3 over 9. Okay, so let's just do that. Again, the denominators are the same. You can actually cross them out. 11 divided by 3 is just 11 over 3, or as a mixed number, 3 goes into 11 3 times, 2 left over, and 3. That's one way of doing it. If you don't comfortable with that way, you can do it by multiplying. So 11 over 9 times, flip it, it becomes 9 over 3. Numerator with numerator, so it's 99. Denominator with denominator is 27. Okay, let's see, 27 goes into 31, into 99. How many times can it go? 99. Well, 3 times it looks. Let's see, 27 times 3. 1, 2, 81. Okay, 81 times, not 81 times, sorry. 3 times, what am I doing? What am I doing? What am I doing? What am I doing? So, 27 goes into 99. Okay, 3 times. And 99 minus 81 is 18. 18 left over, 27. Okay, oh, you're going to say, no, it's not the same. Well, you can simplify 18 over 27. Divide 18 by 9, you get 2. Then divide 27 by 9, you get 3. Same answer. Okay, and I'll actually do it with models as well. So, 11 over 9, we're going to need 2 bars here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, you have 1 over 9, 2 over 9, 3 over 9, 4 over 9, 5, 6 over 9, 7 over 9, 8 over 9, 9 over 9, 10 over 9, 11 over 9. And then you want to see how many times 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 pieces, and you have 3 9s. You want to see how many times 3 9s fit into 11 9s. So let's see. So you want 1, 2, 3. That's one group. You can fit it once. 1, 2, 3. You can fit it twice. 1, 2, 3. You can fit it 3 times. And so we can fit it 3 full times. And then this 3 right here, you're trying to fit it over here. But not all 3 will fit. Only 2 out of the 3 that you're trying to fit. So that's how you get your answer. And they all match with the other ones that you did at the top. 15, page 19. And page 19 is showing up. The model should be included in your solutions. I guess, hope you're getting the hint here. This division of fractions is quite a big chunk, okay, because we're stressing division, in other words, okay, a lot. So a model should be included in your solution. All right, so when the denominators are the same, it's very easy to draw. When they're different, it becomes a little harder. My suggestion here would be to make them the same denominator. So we're going to change this by finding the common denominator. Common denominator between 2 and 4 is 4. So that stays, and then we're going to change the 2 to an equivalent fraction. So it's times 2, it's 4 at the bottom, and obviously times 2 at the top, and you get 12 over 4. Now, much easier to draw this. Okay, so here's 4, something cut into 4. Here's another one cut into 4. We're going to need a few of these, 3 to be exact. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4. That's what 12/4 look like. Okay. Actually, in the corner, I'm going to put 12/4. 12 divided by 4 is the same as 3. Okay. 12/4 means 3 full chocolate bars, and that's what I have. So I'm dividing that by 3/4. What does 3/4 look like? 3/4 looks like 1, 2, 3. And you're trying to fit. See how many times does 3/4 right here fit into those 12/4. So changing colors. Let's see. 1, 2, 3 fits 1 time. 1, 2, 3 fits 2 times. 1, 2, 3 fits 3 times. And 1, 2, 3. And look at that. It fits exactly 4 times. Alright, so, and you'll see that because I have the same denominators, I told you a little trick. You can actually cross these out and pretend they're not there, and it becomes 12 divided by 3, and 12 divided by 3 is simply 4. Okay? Alright, so now we have 2/5, 2/3, I'm sorry, divided by 2/5. And again, my denominators are different, so to draw, I would much rather draw when they are the same. Makes life much easier. LCM, common denominator is 15, so change it to an equivalent fraction where the denominator is 15. 3 times 5 is 15, so 2 times 5. And 5 times 3 is 15, so 2 times 3. Okay. If you want to do this just to back up your modeling, to see if you get the same answer, you cross these out. 10 divided by 6 is 10 over 6, which is the same thing as 5 over 3. Which changed the mixed number becomes 1 and 2/3. Oh, let's see if we can match it with a model. So 10/15. So here you got something that is cut into 15 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there. Something that was cut in 15, you have 10 pieces. And now you have something that's cut in 15, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And you have 6. So you want to ask yourself, how many times can these 6 pieces, 1, 2, 3, 4, 5, 6, fit into 10? Well, 6 pieces, right? 1, 2, 3, 4, 5, 6. So you can fit the 6 pieces in the 6 pieces one time, and you're trying to fit this 6 pieces into these 4 left over. You're not going to be able to put all 6, but you can put 4 of them out of the 6 that you were trying. 1 and 4, 6. And if you simplify that, it becomes 1 and 2/3, which is exactly what we got in the beginning. Alright, and then 7/8 and 1/2. Okay. Alright, so 7/8 divided by 1/2. Okay. So you got a lot of choices here. So this one I actually do all 3. Choice 1, depending on the question. Okay, if they're asking for the model, I would very much change them so that they both have same denominators. So both of them should be 8 because LCM is 8. This stays the same. 2 becomes an 8 by multiplying by 4. So the top by 4, and it becomes 7/8 divided by 4/8. Remember, when the denominator is the same, you can cross them out. It becomes 7 divided by 4, or 7 over 4, which as a mixed number becomes 1 and 3/4. Okay. Much easier, though, is also to draw this 7/8 divided by 1/4 than to draw 7/8 divided by half and then have to cut the half into 8. Okay, this one's much direct approach. So here you have something that's cut into 8, and you have 7 pieces. 1, 2, 3, 4. Okay, so there's something that's cut into 8, and you actually have 7 pieces. 1, 2, 3, 4, 5, 6, 7. So that's 7/8, and this is 4/8. 1, 2, 3, 4, 5, 6, 7, 8. And you have 4. 1, 2, 3, 4. So how many times can 4/8, okay, how many times can, which is this size here, fit into that larger size? How many times can this smaller one fit in that bigger one? Well, if it's 4 pieces, so 1, 2, 3, 4. Here we go. It fits 1 time. Okay, fits 1 full time. And then the 4, you're trying to fit it again, but out of the 4, you can only fit 1, 2, 3. You were successful fitting 3 out of the 4 that you wanted to put in there. So final answer 1 3/4, which is the same thing that you got doing it the other way. Okay. And then page 36. Wow, what a jump. Okay, so page 36. Yay. Alright, page 36 is much direct. It doesn't say draw a model, okay, which I'm pretty sure you're tired of it by now. But so let's calculate the models. No, calculate each quotient, it says. 2/5 divided by 3 1/10. Well, okay, it's a mixed number. Big deal. Change it. So 2/5 stays the same. That becomes 10 times 3 is 30 plus 1, 31/10. Okay, so you got choices over here. You can multiply 2 ways. Okay, you can just multiply by divide it 2 ways. I meant to say. You can divide by multiplying, which is this, and you switch that around. It becomes 10/31, which gives you 2 times 10 is 20, and at the bottom 155. Simplify, divide top and bottom by 4. Okay, and you get 31, 4/31. Okay. That's one way of dividing. Another way of dividing this, okay, is to, yes, change it to both fractions, and if you wanted to, change both so that they both have same denominator. So let me change color. So that was one way right here. The other way would have been, yes, do this first, 2/5 divided by 31/10. And then if you want to keep it as a division problem, find same denominators. Okay, change the problem so that both fractions have the same denominator. So it would be 5 times 2, which is 10. And 2 times 2 on the top is 4. And you get that. Remember, denominators are the same in division. It's nice because you can cross that out. And 4 divided by 31 becomes just 4/31. They both look, that looks pretty easy too. Okay, so you got choices. Next one, 4 1/3 divided by 4/7. Alright, so let's do this with by multiplying. So 3 times 4 is 12, plus 1 is 13. You get 13/3 divided by 4/7. Okay, so I changed my mix to an improper. Now I want to change it to multiplication problem. Keep the first the same. Change that to division. Flip that around. Becomes 7/4, the reciprocal. 3 times 4 at the bottom is 12. 13 times 7 is 21. Goes to 91. What a pain in the butt. I can do 12 goes into 91 8 times, which is 96. No. 7 times, which is 84. There you go. 7 goes into 12. 12 goes into 91 7 times, which is 84. And you have 7 left over 12. That's the problem with changing into multiplication. You always, a lot of times, it becomes into a improper fraction, an ugly improper fraction. Okay, so let's do it another way. I'm going to show you side by side. So again, you want to change it to an improper. Both are fractions. Okay, and if you wanted to change it to least common multiple, you could have. So it's 21. 21. 7 times 13 is 91. and then this would be a 12. And actually, in this particular case, you would cross the 21s, right? Because we're talking about the same units, so it's actually, you can cancel them out. So you get 91 over 12, which again, still, in this particular case, both ways came out to really ugly numbers. 91 over 12, which you didn't have to calculate. So one did not have an advantage over the other. Okay. Now we're doing 3, which is 3 and 1/6, divided by 9/10. Okay, again, change to improper. You get 19 over 6, divided by 9/10. Alright, so let's use multiplication here. 19 over 6 times 10 over 9, reciprocal. If you multiply across, you get 190, divided by 54. Jesus, they're ugly numbers. Who wants to do these? 54 goes into 190 3 times for sure. Okay, and 54 times 3 is 12, goes 1. 3 times 5 is 15, 162. 190 minus 162 is 28. And 28 over 54. And that's going to, you can simplify that by dividing it by 2. By 2, yeah, and you get 3 and 14 over 27. Okay, I'm not going to do it the other way because you're going to get the same ugly improper fraction. Okay, so leave it at that. And I think we have one more. So you got 5 over 8. Please let it be better problem. 5 over, okay, let's scroll this down because that didn't work. Alright, 5 over 8, and you want to divide it by 2 and 7/12. So let's change both to improper. 5 over 8, I'm sorry, second one to improper. 12 times 2 is 24, plus 7 is, I don't know, 31. Looks like a nice number. And let's use the multiply by the reciprocal. 5/8 times 12 over 31. Yuck. 5 times 12 is 60. 8 times 31 is going to be 248, which you can simplify by dividing it by, boo, you can't divide by 3 because the bottom is not a thing of 3, so divide by what? By 3? So 60 divided by, no, you can't divide by 2, be 30 over 124. Oh yeah, I can divide it by 4, I'm sorry. And divide again by 2, you get 15 over 62. Final answer. Okay, let's see if the other way helps. So the other way would have been, and I'll change colors. Okay, instead of multiplying by reciprocal, you're going to keep it as a division problem. So it's 5 over 8 divided by 31 over 12. Now find the LCM, which in this case is 24. So find two equivalent fractions here. So the 8 become a 24 times 3, so it's 5 times 3, 15 on top. 12 become a 24 times 2, so it's 31 times 2, which is 62. And, wow, this one, much easier doing it this way. So both denominators are the same, so I mentioned you can cross it out because we're talking about same units. And 15 divided by 62 is simply 50 over 62, which you can't simplify anymore. Okay, and I think that was that. Well, it isn't that bad. Okay, and I'm missing something. All right, so let's see. What should I write here? I can write. There. That's my message today. It's actually true. All right, that's it.